Alright, this is the second section of actually chapter 1. It's basically the only section that we're really going to do within chapter 1 itself. So, talking about just basically measurements, the different types of measurements, things like that. So here we go. Alright, units and standards. A standard is an exact quantity that people agree to use and compare measurements to. So, for example, everybody has different size hands or different size feet. Feet? Yeah, exactly. Feet. Feet. So, back a long time ago, people would measure things and they would say 3 feet or, 3 hands. And then they realized that everybody was getting different measurements. So what they would finally did was they said, well, we need to set a standard because, everybody was getting different measurements based on different size hands and different size feet. So we have a standard. And then eventually we have an actual measurement system. Measurements must include a number and they must include a unit. So that's what a measurement must include. A measurement is called a quantitative observation, an observation that includes a number. And of course we have to have a unit with it, meaning a milliliter, a liter, a gram, a mole, whatever it may be. Here in the good old US of A, of course, we use what's called the English system. The English system consists of a foot, gallons, pounds, miles, things like that. Pretty much everyone else around the world uses the metric system. The metric system is based on multiples of 10. And of course we've already talked about basically how to convert metric system just a little bit. In science itself, though, we use the International System of Units. It was founded in 1960. They actually sat down and had a convention in Germany, and it's basically what they consider an improved version, of the metric system itself. It's abbreviated SI, so it's basically, this is a system that scientists use across the world. We all know that if we're going to use a distance measurement, we all use this same exact unit. So it's not like, well, do we all use kilometers? Do we all use centimeters? Do we all use millimeters? We all know that we use this exact unit so that we all don't get confused on what we're talking about. So it's universally accepted throughout the world. So each SI measurement has what we consider a base unit, a specific unit that we use for distance, for time, for speed, for everything. So every SI measurement has a number and a unit, and there are 7 base units. You'll find out in chemistry, 7 is like the magic number. There are lots of things that have to do with 7 within chemistry itself. So I've always considered 7 kind of my lucky number. But maybe that's just because I'm a chemist. But alright, so here are your 7 SI units. Any other unit that chemists need are based from these 7 units. So if we need anything else, we take them from these units here. So we have length, we have the meter is what we use, so we symbol M. If we're measuring mass, we use the kilogram, kg. So notice we don't use grams, we use kilograms. Time, second, little s. For measuring electric current, we use the ampere, A. For doing temperature, scientists always use the Kelvin. So we don't use Celsius, we don't use Fahrenheit, we always use Kelvin. The amount of a substance, we use the mole, abbreviated MOL. I know, that abbreviation is just crazy, but the intensity of light, we use candela, abbreviated CD. So the expectation is that you guys are going to learn this chart and know basically this entire chart. I should be able to ask for any piece, and you should be able to give me any piece, whether it be this or the units or the symbols. Okay, so make sure you know that. we already talked about. So then from there you can obviously take your SI units. Again, they're based on the metric system, so you can use multiples of 10. You can use prefixes, just like we did with the typical metric system, so you can see your metric notes on that and go from there. So just talking through some of these things. Measuring distance, that's called length. The definition of length is the distance between 2 points. To measure length, we use the meter stick or metric ruler. Those are the appropriate devices. We did that a lot first semester in physics, and so the SI unit, of course, is the meter. Now, measuring volume, if you looked at the chart, there was no specific thing for volume. There wasn't milliliters or liters or anything like that. So of a solid, what we do is we use our meter measurements. We do volume, we do length times width times height. So length times width times height would technically be a meter cubed. Most of the time, though, what we do is we a lot of times use centimeters cubed, though, because it's a smaller unit. In the medical community, a lot of times you hear this referred to as cc's. So I'm going to give you 3 cc's of something, which is referred to as cubic centimeters. For a liquid, we commonly, though, use liters or milliliters just because it's easier. And we used graduated cylinders to measure that. The relationship is 1 centimeter cubed is equal to 1 milliliter. So those are exactly the same. So if you're going to get a cc of medicine, that's the same thing as giving you a milliliter of medicine. Okay. If you're going to measure matter, mass, you're measuring something's mass. It's a measurement of the quantity of matter in an object. So the SI unit of that is the kilogram. We commonly, of course, use grams because a kilogram of chemical would be a ton. Not really, but so a gram is much more reasonable. And the proper device to use, of course, is the balance. We've used that a couple of times this year. We've measured time several times this year, and that's time is defined as the interval between 2 events. The SI unit is the second. We use a stopwatch, of course, or a clock with a second hand. Temperature, we've measured temperature a couple of times this year. We've already talked about, it says learn later, but we did physics first. We already learned what the scientific definition of temperature is, so this definition is actually probably pretty, incorrect. We already know what the definition of temperature is if you took physics. So units of temperature: Celsius, Fahrenheit, Kelvin. Kelvin, of course, is the SI unit. Of course, we don't use the degree symbol with Kelvin. 0 Kelvin is the coldest possible temperature that you can possibly get to. It's known as absolute zero. That's the point at which particles cease to move. There's no volume. There's no movement within the particles themselves. It's equivalent to negative 273 degrees Celsius. So we've never been able to obtain absolute zero. We've been able to get pretty darn close, but it's never been achieved. Here's your temperature scales, just to kind of refresh. You probably know these, but Fahrenheit, if you want to boil, and this is talking about water, boil water for Fahrenheit is 212, freezing point's 32, so that's why if outside, when we watch the news and stuff, if it gets below 32, we're at freezing. Celsius, you boil water at 100 and you freeze at 0. Kelvin, 373 is boiling and 273 is freezing. You could kind of notice the relationship between boiling with Celsius and Kelvin. Notice that it's just the difference of 273. So if you add 273 to your Celsius, you get the Kelvin temperature. Okay. So that's what I was talking about, some conversions here. So if I want to take this Celsius temperature and get it to Kelvin, all I have to do is add 273. So 25 plus 273 is 298. Kelvin. Okay. So Celsius to Kelvin, you add 273. If you want to go the opposite way, where you get Kelvin to Celsius, just subtract off that 273. So if I have a degrees in this case of 445, and I want to take away 273 and to get to Celsius, I get 172 degrees Celsius. And notice that I did not use that degree bubble with the Kelvin, but I did with the Celsius. Okay, so those are the basic temperature conversions that we'll do in here, just getting from Celsius to Kelvin and Kelvin to Celsius. Okay, and that should finish up our notes for the first part of section 2. We'll get into density and stuff like that a little bit later.